Hello, today we're going to talk about circles. So a circle is an infinite number of points that surround one dot right here, and this is called the center. Okay, and when we are talking about circles, we have a lot of new definitions here. First definition we have is if we are starting from the center of the circle, how far is any point on this circle away from that center? And we call this our radius. Radius. Now we also have a what about the entire distance? So what if we didn't start in the center and work our way to the outside? What if we went all the way across? So if we had a line that went all the way across through the middle of our circle from one side to the other, we have a new name for that. That is called our diameter. And we can use our radius and our diameter to help us solve problems that we are going to see dealing with area and circumference. So before we begin with area and circumference, we have one more word here that I wanted to make sure we know, and this is pi. Pi is an irrational number, meaning it cannot get turned into a fraction, which means it never terminates and never repeats. It follows the same pattern every single time, but there's not really a specific pattern with our decimals. Now, sometimes with pi, we approximate it and we say, you know what? Pi is about 3.14. It's not exactly. Pi goes obviously to billions and billions and millions and trillions and quadrillions of decimal places, but it's about 3.14, and we can use that to approximate. That's one of the ways we can use to approximate. Another common one that you may see is 22/7. And a third one that you may see is actually just using our calculator. And let me bring up our calculator right here. And if you actually just click the pi button on your calculator, depending on your calculator, it will tell you pi to any certain number of digits. Obviously, the one I have here has a lot more digits than your standard calculator that you are going to use in your hand. So we can use this information to also solve anything to do with circles. And what pi really is, where this number comes from, is someone a long time ago found out that, you know what, if we take the circumference, which is kind of like our perimeter here, and divide it by the diameter of our circle, we always get this number pi. And because of that, we can use pi to help us solve any type of problem dealing with area or circumference that I would need to look at. So before we actually start solving some problems, let's take a look at our formulas. So the two formulas we have, one of them actually is made up of what we just saw right there. And that is our circumference is equal to pi times our diameter. So if we had a value for this diameter here, for my circle, the distance all the way across through the center, all we would need to do is multiply it by pi to get our answer. So if, for example, I said this diameter right here is 4 feet, I can then use the number 4 and say, you know what, this is 4 pi feet. Super easy. Or I could approximate this using any one of our measurements. I'm going to use 3.14 just to show you how that is going to look. 3.14 times 4 approximates my answer at about 12.56 feet. Now, obviously, this is not exactly 12.56 feet, but it is close to that amount right there. And we leave this in feet because this is kind of like my perimeter. Circumference and perimeter are very similar, except perimeter is usually adding all my sides together. We don't have any flat straight lines in a circle. So therefore, we cannot just add sides together. We need to use this new formula. Now, area is what we call the inside, and that's very similar to how we would deal with squares, rectangles, triangles. We do the same thing with circles. Now, of course, area is measured not in feet, but in square feet. And that brings us to our new formula right here. Pi times radius squared. So dealing with this same problem here with a diameter of 4, we would need to start this problem off by actually not dealing with our diameter, but by finding the radius first. Now, as I already mentioned before, the radius is actually going only halfway across our circle. It basically starts at the center and works our way to one of the sides, any part of the circle. So this would be half of our diameter here. So if the diameter is 4, in this example right here, the radius would be 2. And this was a very easy one to use because 2 squared is actually just 4. So this, once again, gives me 4 pi feet squared. Also known as, once again, since it's the same number here, very convenient, 12.56 feet squared. And once again, every time we do area, it has to be in square units, square feet, square inches, square miles, because the area is how much space we have inside. And we can't just draw a line here. We'd have to make tiny little squares measuring however many, in this case, feet, foot by foot squares. We'd be able to fit 12.56 of them inside this circle right here. So now we're going to look at some state test questions. This is New York State test questions dealing with circles and see if we can use this new information to actually solve them. Our first question says a circle has a diameter of 26 units. What is the area of the circle to the nearest hundredth of a square unit? Awesome. So in this problem here, we need to start off with a circle. And whenever I see a problem like this, I actually always start by drawing the circle out. It's easier to visualize what exactly I am talking about in my problem before I actually just start, using a formula and solving here. So this problem here, they give me some information. They are telling me, look at, we have a diameter, very important, diameter of 26 units. So this distance going straight across right here, all the way through, is 26. Now going back to my formula from the previous page, area equals pi times radius squared. I do not have enough information at this point to solve this. They give me the diameter, 26 units, but the formula asks me for the radius. So just a recap, to find the radius of the circle, we're going to take our 26, divide by 2, and it gives us 13 units right here. So I'm actually going to use the number 13 as my radius in this problem. Now, I would highly recommend using a calculator here. Don't want to estimate this and make any mistakes. Bringing up my calculator, first thing I'm actually going to do is the square. PEMDAS, order of operations. We must do our exponents before we do our multiplication. 13 squared, aka 13 times 13. Most calculators do have this, most scientific calculators, I should say, do have this squared button right here. So if I click that, I get 169. Same thing if I actually did 13 times 13. Still get 169. So my area in this problem is whatever pi times 169 is. So I should take this, multiply times my pi button, you are. It equals, and it gives me an answer of 530.929, etc., 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 which is clearly going to give me an answer of choice B. Now with this one here, we definitely could have approximated because these numbers are so far apart right here and we had answer choices. But usually when you see something that says, what is the area to the nearest hundredth or nearest thousandth or nearest tenth, you want to use the actual pi button on your calculator because you want to get as close to the actual answer as you can. So let's try one more. Take a look at one more problem here. Keo used wire fencing to form a border around a circular region in his backyard. If the radius of the circular region was 5 yards, what was the total length of the border rounded to the nearest tenth of a yard? So this is our second question in a row where we are actually looking at finding an approximate answer for our question. It does not tell us what value of pi to use. It doesn't tell us to leave pi in our problem. It wants us to round our answer, in this case, to the nearest tenth of a yard. Now I'm going to start this problem the same way I started the last problem and draw my circle. But this time we have a different piece of information. They don't tell us my diameter. This time they tell us the radius of my circle is 5 yards. So the distance going from the center to any point on the circle, that is what's going to be 5 right here. Which would help me normally if I was dealing with area. But this time we are trying to form a border. And a border goes all the way around the outside of my circle. So this question here is actually dealing with circumference. Circumference equals pi times diameter. Or I actually probably could say, you know what, it's just 2 of my radii, 2 of this radius that I have here. This is 5 going across. Going across would be another 5 if we were to continue that line. So my diameter in this problem is 10. So all we need to do is take pi and multiply it by 10. Take my calculator. I'm sure it's actually pretty obvious which one is the answer, but we will use our calculator nonetheless. Pi times 10 equals 31.41592, etc., 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 aka about 31.4. My suggestion when you are trying to solve this problem, if I were to give 2 helpful hints to solving any problem dealing with circles, I would say step 1, draw the circle. It's very helpful to visualize what exactly is going on if you have the circle drawn and tells you what you actually know. And the second piece of information, second hint, helpful hint that I would give you guys to help you out is to look and see if you know or need the radius and diameter. A lot of times, especially in the 2 problems we just solved, 2 exact state test questions we just looked at, a lot of times they are going to tell you the diameter, but you need the radius for your formula. Or they'll tell you the radius and you need your diameter for your formula. The other answer choices are there to trick you. Do not fall for their trap. Make sure, do I know the radius? Do I need the radius? Do I know the diameter? Do I need the diameter? And that is it.